Hello everyone. Today, we will learn the basics of motor control. A motor converts electrical energy into mechanical energy and is widely used in devices such as robots, fans, and pumps. In this lesson, we will introduce the working principles of motors and how to control them in a circuit. In our project, the car uses an electric motor as the core driving component, responsible for controlling its forward movement, reverse movement, and steering. The motor consists of an electric motor and a gearbox. The motor is the power source. Its working principle is to generate a magnetic field through an electric current, which drives the internal rotor to rotate, converting electrical energy into mechanical energy. The gearbox, on the other hand, is used to adjust the motor's output speed and torque to meet the movement requirements of the car. The car typically uses a DC motor. When the battery supplies power to the motor, the current flows through the motor coil, generating a force in the magnetic field that drives the motor to rotate. This rotational motion is transmitted to the car's wheels through a transmission mechanism, enabling the car to move. By changing the direction of the motor's current, the car can move forward or backward. By adjusting the current or using pulse width modulation, the speed of the motor can be controlled, thereby controlling the speed of the car. In this section, we will use TinkerCAD to simulate motor control. First, we will use a switch to control the motor's on or off state. Drag a breadboard, battery, motor, and switch from the components library to the workspace. First, connect the battery to the breadboard. Then, connect the motor's negative terminal to the breadboard and its positive terminal to the second terminal of the switch. Next, connect the third terminal of the switch to the circuit. Click Start Simulation, then toggle the switch to see the motor start rotating. Next, let's use a switch to toggle between two motors, ensuring that only one motor runs at a time. Connect the positive terminals of both motors to the first and third terminals of the switch, respectively. Then, connect the second terminal of the switch to the power line. Finally, connect the negative terminals of both motors to the negative rail of the breadboard. Start the simulation and toggle the switch. When the switch is flipped to the left, the right motor rotates. When the switch is flipped to the right, the left motor rotates. Finally, we use two switches to control the forward and reverse motion of the motor. Connect the first and third terminals of both switches to the power line. Then, connect the positive and negative terminals of the motor to the second terminal of both switches. After starting the simulation, you can observe the following. When both switches are on the left side, the motor's negative terminal is at a high level, and the positive terminal is at a low level, causing the motor to rotate in reverse. When switch 1 is on the right side and switch 2 is on the left side, both the positive and negative terminals of the motor are at a high level, causing the motor to stop. When both switches are on the right side, the motor's positive terminal is at a high level, and the negative terminal is at a low level, causing the motor to rotate forward. When switch 1 is on the left side and switch 2 is on the right side, both the positive and negative terminals of the motor are at a low level, causing the motor to stop. Next, you can use the Clear Robotics Kit to conduct an actual motor control experiment. Today, we learned about the working principle of motors and mastered the basic methods of controlling motor movement through simulations and experiments. Through these practices, you have not only deepened your understanding of the motor's role in circuits, but also acquired basic motor control skills. In the next class, we will learn how to use motor driver chips to control motor movement more efficiently.